Welcome, everybody. Good to have you. Today we're going to have our very last session. It's been 2 months. We've covered lots of things. Today we have two more topics. First one is right angles and trigonometry, and the last topic is circles. They are relatively easy topics, so I don't think this will require too much effort from your side today, at least. And with nearly 7 minutes on the clock, we can start with our very last topic, which is circles. And we have only one easy question, so we can say that we did all the easy questions. Just do this. And, nobody's gonna find out anything about it. But anyway, so we have this. It's a question. It says that the circle has something called the circumference. Circumference, just discussed, I don't know, 2 minutes earlier. It's just the outer fence of the circle. Think of it as follows. And this outer fence, if you have a circle which has radius r, this outer fence is equal to 2 times phi times r. Phi is an interesting constant. I think it's 3.141519265358979323846264333832. Something like that. Normal. So this is the constant. Pi goes on forever, but it's still a finite number. It's weird. Infinity is weird. Anyway, we would like to find the length of the arc AC. And I wouldn't really say that this is a particularly difficult question if we pose the problem as follows. So if we want to find the length of a whole arc, it's 2 pi r. And what if we want to find the length of half of the circle? It's pi r. It's just pi, just the phi is divided by 2. Well, let's take note of this phenomenon. So in the first case, we had 360 degrees. So we had the full rotation. And maybe you can tell me why you said it's going to be just pi r divided by 2.
Because it's half of the entire circle.
Yeah. And how did you know it's half of the entire circle?
Because 2 pi r is 360.
Yeah, and this is 180, it's just a straight line. And you can generalize this. So if you, this is just an example, of course. So this is going to be 2 pi r times the ratio of 180 with respect to 360, which is a half. So this is effectively what's happening. I'm just expanding on what we just did. As a matter of fact, if you just take an arbitrary cross-sectional part, be it area or circumference, and let's say it has an angle theta, then you find out what this angle theta is with respect to 360 degrees. It's like you have a pizza with 360 slices, just seeing how many slices you took out of it. And from there you say, okay, I divide this by 360. I took this much out of the whole 360 pieces of pizza, and you multiply this by, well, the size of the whole pizza, which is always 2 pi times the radius. So this would be your radius. You see how this goes?
But how do we find the
How do we find this for now, for the problem that we have now?
let's say pi? Or sorry, theta. How do you find theta and how much pizza it?
So usually it is either, so it's either, it's one of three things. You're either given the so if I call this L, So L is equal to theta over 360 times 2 pi r. You're usually given two of them. You're usually either given L or theta and asked to find r. Either given L or r, L and r asked to find theta, or you're given theta and r and you're asked to find L. And I think that's the case here. So here we have theta. What is the value of theta here? What's the value of the central angle for the arc? Maybe I should use this annoying thing here. No wonder you weren't getting that. So this is AC. And I take the arc. What is the central angle? 90 degrees, right? And 90 degrees out of 360 is a quarter. So at least intuitively we have the understanding. If it was a more obscure angle, we would do the same. So I say it's 10 out of, okay, 10 is not obscure. I don't know, 15.5. Okay. Sure. Just divide by 360, find the ratio, and then it's good. So let's effectively do that. We take 90 out of 360 of the whole pizza, let's say. And what's the outside length of this pizza? So yeah, so it's 2 pi r, but at the same time, it is given to you for free here. So it's 90 divided by 360 of the whole outer fence. What's the whole outer fence? It's the circumference. What's the circumference? 36. So you don't really need to write 2 pi r. You're given 2 pi r for free. So you just write 36. And then this is very nice. You just divide 36 by 36. The 0 goes with the 0. Then the answer is 9. So this is something you don't really need decimals for. Okay, that was annoying. But I hope this explains it.
Sorry, can you go back up for 1 second? I just wanted to look at the. Okay, we're good. Never mind.
Yes,
Thank you.
of course. Now I just want to do one more problem. That's okay. You know, your math teacher used to always say, you know, like this one more problem at the very last second, and they would spend forever. And then I would always get upset, you know. But now you're doing it. Yeah, now I've become the villain now. Don't sleep well ever since.
I learned something new today. I thought in SAT there's just the mean and what was it?
Okay. There's a mode.
But there is also one more thing, range.
What? Range, yeah. I mean, just think.
Yeah, just a bigger number minus the small.
Yeah. Okay. So this is not too bad. Here's this. So we've talked about this a few moments ago. 180 degrees is pi radians. Then the question is 720 degrees. Okay, let me not say this. I'll just write it down. So 720 degrees is what? Two, three sixties. Two 360s.
360s twice.
Yeah, so this is 180 how many times? Yeah, 4 times. So it's 4 times 180 degrees, which is on the other hand 4 times pi radians. Right? Then if he's asking you about the value of A, and this is equal to precisely 8 pi radians, then you can just compare the coefficients, and then you would get that A is equal to 4. So could you repeat that? Yeah, I was just saying that finally, to conclude, here we have that the number of radians can be written as a pi. So on one hand, I have 4 pi radians. Is this okay?
Yes.
4 pi radians. On the other hand, I have a pi radians. So I should write radians.
But why did you choose 180 as the pi radians then?
Because this is a definition. We mentioned this I don't know, 10 minutes ago. So we were talking about how 180 degrees is the cross-sectional angle you would take in a unit circle in order to get a length of pi on the outside. Right? So this is all of this is 2 pi. This part is just pi. And 180 degrees is the angle such that if you are in the unit circle, like we are here, you would get the fence, the outer fence, and the length of the arc, you could say, to be equal to pi. So it's the angle that makes the arc equal to pi. This is what this 180 degrees is. This is how it's defined. And we can extend this by saying, okay, 180 degrees is 1 pi radians, then 4 times 180 degrees is 4 times 1 pi radius, it's 4 pi radians. Finally, we are asked to write our number of radians as a pi. And then we compare the coefficients to conclude. Is this good?
Then we compare the coefficients.
Yeah, because here's this. I have a pi. I have 4 pi on one side. I use this fact and I equate my 4 pi to a pi. So I get that a is equal to 4. Because here I have pi, here I have pi. I have radian. Then it must be true that R4 is equal to a.
For me, I always use the formula that pi over 180 degree. If I want to change from degrees to pi, if I want to change from pi to degree, I use 100 degree over pi. It's always from
Well, you see it here. 180 divided by pi is 1 radian. And 1 degree is pi over 180 radians. This is precisely what we have here. And you don't need to memorize it per se. You just remember that the 180 degree angle is the angle such that I get pi in the unit circle.
Yeah, logically,
Then it is possible. Actually, you don't even need to memorize this. That's the thing. You don't need to memorize that it's 5. You just know that it's the length of the arc in the unit circle, which has a central angle of 180 degrees. Then in your mind, you should draw a unit circle, which has the full radius of 2 pi. Then the radius of half of the circle is going to be just pi. So I'm not trying to give you rules here. I'm trying to give you a way to infer how you should proceed. I think that's more powerful. I think it's more interesting as well. But do you have more questions? Or is this good?
The answer they before.
Yeah, so the answer is just A equal to 4. And this is actually more than just good. It's great. It's, we're done officially with all of the skills. Hopefully with all of the training for the course.
Months of training was.
Yeah, 2 months of training. Yeah. Yeah.
I wish I was here earlier.
Yeah, it's a bit unfair because you didn't really get the chance to do it.
I just hope it doesn't affect my,
No, hopefully it will be okay. Close.
Are you here on campus tomorrow now?
Tomorrow and after. I'm not sure, but I was thinking of scheduling something right before the exam. So I would give you tips and tricks on how I would do the SAT if I were doing it, the next day.
So like Friday night.
I still need to confirm this. I still need to look into my schedule and set a time slot, but it should be possible. Should be possible to arrange that. It would be here as well. I just need to sit down and communicate it on Teams.
Mhm.
I'll probably add you to Teams as well. Yeah, in the end, I just want to say thank you so much for this. It's been an absolute pleasure. At least from
Your time.
yeah, of course, from my side, this is I think it is very important for me to be here and try to explain things to you that might seem obvious, but they're actually very difficult. And I would like to say that you guys are doing a great job, because it looks easy, it's not easy. It's very challenging. You need to put in the work, you need to put in lots of effort, and it is very easy to give up. But you guys are not giving up. I'm happy to see that, and I'm here so that you can do your best in the exam. And I hope you had fun while it lasted, because I definitely did. Yeah, I'm really bad with goodbyes. This is my very first course, and so I'm personally also proud and honored to have shared this experience with you guys. Thank you very much, and hopefully I'll see you very soon.
If we only had a similar structure in English.
We're being recorded. I have to cut this.
I didn't know this.